Hello, Algebra 2 students. The last couple of sections we've been working on rational function graphs and understanding kind of what the graph of a rational function looks like. Now we're going to go into the next part of this chapter, which is using the expressions and the equations and kind of working with them, doing the algebra. Um, so we're going to work today. We're working with rational expressions and simplifying them as well as multiplying and dividing them. Okay. So if you notice, simplest form of a rational expression means that the numerator and the denominator have no factors in common. You may have to restrict certain values when you're in simplest form because the division by zero is undefined. So if you take a look in this first example here, okay, this looks pretty messy. And they want you to write that in simplest form and state any restrictions on the variables. So if we take a look at um, step number one here, okay, first thing you're going to want to do is go through and factor, okay? Factor the numerator, factor the denominator. Remember, step number one of factoring is to go through and factor out any common factors. So if you notice that you can factor out a 6 out of each of those, you can factor out at least an x out of each of those, and you can factor out a y squared out of each one of those terms. So that's what they did in the numerator. Notice in the denominator, 3 is a common factor. There are no x's in both, so we can't do anything there, but we can factor out a y cubed. So that's what they did, is factored those things out first off. Okay? Then, if you look at what's left in parentheses, you can factor each of those even further. So x squared plus x minus 2 factors to x plus 2, x minus 1. Denominator, you've got a difference of squares, so it factors to x plus 2 and x minus 2. Okay? Then at that point, now what you're trying to do is you're trying to simplify the factors that can cancel. Okay? You're going to divide out the common factors. So if you take a look at that, they went through and they completely factored probably further than you need to. Okay? They took the 6x squared, xy squared, factored the 6 into 2 to 3, and then put the y squared as y times y. Basically, if you take a look at this point right here, you can notice you've got an x plus 2 and an x plus 2. Those cancel and go away. Okay, that's the first part. 3 goes into 6, okay, 2 times, so you can cancel the 3 out. 6 becomes a 2. Okay, that's still there. X is going to stay in the numerator because there's nothing in the denominator to cancel it. And finally, this y squared will cancel out 2 of the y's in the denominator, and therefore that's why there's one y that's left. Okay, so those are the things that cancel, and therefore here is what is left, is what you're looking at. So that is the simplified version of what we started with. Okay, but then we have to go through, and the last thing we have to take a look at is what are our restrictions. Okay, so if we take a look at the original expression, if you notice, when our factored form before we canceled anything, is undefined if, the reason they say 3y squared equals 0, that's one factor. If that factor equals 0, then this whole denominator equals 0. That's the exact thing. This is just the zero product property is what they're doing right here. Take each factor, set it equal to 0, and solve. So that means on this one, if you divided both sides by 3 and then took the cubed root, you'd get 0. Here you subtract the 2 over, here you add the 2 over. So what that means is that you cannot have any of these values. Okay? So when you then look at the simplified expression, what they're trying to have you look at is, notice, you still get y cannot equal 0. You still get x cannot equal 2. But what you need to notice is you had canceled out the x plus 2 as factors, and therefore those went away if you're only looking at your simplified version. So when you are trying to figure out what your what values x or y or whatever the variable cannot equal, any restrictions that you might have, you need to look at the original factored expression to figure that out. Okay? Because if you were taking a look at this and you went back and you plugged x equals negative 2 back in, well, it's not allowed to be plugged back into the original problem. The simplified one, it works just fine, but we're working on the original problem. Okay? So notice, here's the original problem. simplified with here's our restrictions on our variables, okay? And that's coming from the original factored expression. These first 6 problems are exactly that. Go through, factor the numerator, factor the denominator, simplify, cancel any common factors, and then from there, look at your original factored form and figure out what your variables cannot equal. If you do that, one thing I want to make sure that you understand as you're working on your canceling, you cannot cancel terms. You can only cancel factors. So for example, I can't take a look at something and say, oh, I can cancel this x with that x right there. Or like even in my final one, I can't say that this x and that x cancel out because they're part of a factor. You either cancel the whole factor or not, okay? You cancel factors, you do not cancel terms. So that should give you an idea there. Then on the back side, now we're actually doing an operation here with those. It's just kind of 1 or 2 extra steps is all we're doing. Notice it says to find the quotient. When you just multiply by the reciprocal. The divisor is the second part, okay? So all you're really doing is when you divide by a fraction, you're multiplying by the reciprocal, okay? So if you take a look at this example, step number 1, notice this is a division problem. So the first thing they're saying is, let's go through and instead of have a division problem, let's rewrite it down here as step 2 as a multiplication problem instead, okay? And then from there, then you're going to take a look at, all right, now let's try to go through and factor each one of these expressions as much as possible. Let's put them in factored form. So this x squared minus 2x minus 35 factors here to x minus 7x plus 5. Second factor, you can take out an x, and then you'll be able to factor what's left will be a difference of squares. That's where this is coming from. In the denominator, you can factor out an x squared, and then you're left with 2x minus 3. Second factor down here, you can take an x, or excuse me, a 7 out, and that'll leave you with x minus 7. Okay? So then at that point, the last thing that you're looking for is, all right, let's take a look at all these factors and see what cancels. Okay, because I put them all together already when I multiplied. So notice any factor in the numerator will cancel with any factor that's in the denominator. So if you notice, we've got an x minus 7, x minus 7. Those will cancel out. If we take a look, there are no x plus 5s down here, so that's going to stay where it's at. This x right here is a factor, and therefore can cancel out one of these x's that is also a factor. Okay? 2x plus 3 doesn't work out. There is a 2x minus 3 that does cancel. So at that point, if you go through and we get rid of all the common factors and we do our simplifying, here is what is left. The x plus 5 times 2x plus 3 all over 7x. And you do not need to go through and multiply this back out. You can just leave it in factored form. That is perfectly fine with me. Like I said, you do not have to go through and multiply it back out. Okay? The last thing, just like on the other side, you do have to put the restrictions down what x cannot equal. So if we come back up to our factored form that we have here and we start looking at our denominator, x cannot equal 7. Okay? That's why that is there. If you went through and you took, what am I looking at here? I'm going to actually go back to here. I think it'll be easier. If we go through and we take a look at, so if x equals 7, this factor would be 0. If you went through and you took a look at this factor, that's where they're getting the 3/2 from. And then the other x squared is where they're getting the 0 from, okay? So just a heads up that that's where these values are coming from, is again, the denominator cannot equal 0, therefore they're just setting each factor from the denominator equal to 0 and solving. Okay? And actually, technically this is a typo. That should not be plus or minus, it should just be a positive 3/2. Okay? So same idea down here. Rewrite these division problems as multiplication, do all of the factoring and can then cancel all the factors, don't forget to state the restrictions that are on the variables. Okay? Again, as always, reach out for help if you need it. Ask some questions if you're needing any help at all. Okay? Have a good day, everybody.